Good morning. I am Rathi Devi, Assistant Professor in Department of AAA, JJ College of Engineering and Technology. Today we are going to discuss about the introduction of digital logic circuits. The contents are what is digital electronics and the analog-based digital circuits, binary systems, basic classification of digital circuits, combinational gates, representation of digital information, digital abstraction, logic levels and the benefits of digital systems. First, we have to know what is digital electronics. So, computer generally deals with digital information, that is the information which are feeding to the computer is generally in the forms of zeros and ones. These are called binary digits. Digital electronics represents informations in the formation of two discrete values which are zeros and ones. Ideally, if there is no voltage means it is represented as 0, and if there is full voltage is given means it is represented as 1. Realistically, 0 voltage or full voltage is not applicable in practically. So, we are taking that less than 1 voltage as 0 and greater than 4 voltage as 1. We achieve these discrete values by using the switches. Here we are using the transistor as the main switcher. Because it operates at high speed, it is very small in size. Now we are going to discuss about the comparison between the analog and the digital circuits. What is analog system? Analog systems means it deals with the time varying signals that can take on any value across a continuous range of voltages in electronic and electrical circuits. Digital systems process time varying signals that can take on only one of two discrete values, which is zeros or 1, that is low level and then high level of voltages. Discrete values are called here 0 and then 1. In digital circuits, we are using the binary values, that is zeros and ones. Here, why we are using this binary value means when we are considering the electronic signal, the binary values have only two values, that is 0 and 1. When we are taking the octal number system means it is having 8 levels, that is 0 to 7. So totally there are 8 variables, but in binary we are having only 2 variables. So according to the digital design and cost wise comparison, binary value is better than any other number systems, because decimal we are having 10 numbers, octal we are having 8 numbers, but only 2 numbers are used in binary system. So this is most easily designed number system, and the cost level also very low when compared to other number systems. So the types of basic digital logic circuits are, basically it is divided into two main categories, that is combinational logic and then sequential logic. Combinational logic means the output of this digital circuits depends only on the input logic values. When we are going for sequential logic means the output of this circuits not only depends on the input values, but already the stored value of the inputs also affect the present output here. And then gates are the basic main blocks of combinational logic circuits. Here the most basic digital devices are called gates. Gates, why they are called in this name means, according to the function, it can allow or block the flow of digital information. That's why these elements are called as gates. A gate has one or more inputs which produce a single output. A gate is called a combinational logic block. 3 most important gates are AND, OR and NOT. These are all the basic logic gates. So these are the types of combinational logic gates. Here the first 3 comes under the basic gates, and the XOR and XNOR are called universal gates, because we can construct any other gates by using these 2 gates. So these 2 gates are known as universal gates, and these 3 gates are known as basic logic gates because all SOB and POS functions can be solved by using three gates. These three gates. And then now we have to know how we represent the digital information to the logic circuits. By using the discrete voltage levels, these information can be used to represent in a digital circuits. So here the switches are representing the digital information here. Here the low level is represented like this. This is the low level input is given and the high level output is taken. In this circuit, the high level output is given and the low level output is taken. How we are getting this output here means these are the switches. When we are operating these switches, we are getting the output from this input. Actually, when this switch is closed means it is represented as 1. When the switch is open means it is represented as 0. Here the level of voltage is kept as low. Here the VDD voltage is kept as high level. As we already know that high level voltage is connected to the low level voltage, then there will be a flow of current. Similarly, if there is a low level of voltage is given here, this switch is kept closed means so there is a path created and this voltage level is maintained and we can take this as high level voltage in the output side because it is not grounded. But when this high level voltage is given as input means these switches kept open and these switches is kept closed. So this voltage can't connect to the output level, but the ground level is connected to the output level. So the output level is approximately is equal to 0. So it is low level. It is considered as low level. So these are the real switches how we are represented in the digital information. So instead of this we are using resistors also. So digital abstraction, it is difficult to make ideal switches completely on or completely off. So some rules that allow analog behavior to be ignored in most cases. So circuits can be modeled as if they really did process zeros and ones, known as digital abstraction. Digital abstractions allows us to associate a noise margin with each logic levels, that is zeros and ones. So undefined region, here you can see the logic levels here. If the voltage is greater than 3.5 volt up to 5 volt means it is taken as logic 1. If the voltage level is 0 to 1.5 volt, it is taken as 0. So the in between gap is taken as inherent digital. So it is we are keeping the noise margin like this. So when comes to the advantages, so digital over analog circuits. So digital circuits, that is the digital circuits can reproducing capability. So we can reproduce the data from the digital signals and it is less affected by the noise because there is error detection and error correction ports are available in digital circuits. So we can retrieve the original information from the data. So it can easily design and the data protection is very good in digital circuits and it is easily programmable. The speed is very high when compared to the analog circuits and it is more economical when compared to any other analog circuits. So this is the introduction of digital logic circuits. Thank you.